So hi everybody, my name is John Kilpatrick. I am a network architect for NVIDIA, and I'm going to talk a little bit about IPv6 and how dynamic addressing works and things that you should probably know before you try to go deploy your first IPv6 network. So why do I love IPv6? It's because NAT sucks. It's a hot piece of garbage and it gets in my way more often than not. Anybody who games on console has probably run into either of these scenarios. Hey, I can't hear you. Can you hear me? No. Why? Okay, whatever. Let's go. Now, you're probably wondering, well, why should I care about IPv6? Gretchen, stop trying to make IPv6 happen. Well, the reality is, and you saw this slide yesterday, 30% of Google's user traffic is native IPv6 today. So it is a thing, and it's out there, and you may run into a use case where you need to deploy it. The IPv6 address is 128 bits, as we learned yesterday, and it's basically broken up into two halves. One half is the interface identifier, and that's what we're going to be talking about today. The smallest v6 VLAN you're going to run into is a /64. If you ever try to go beyond that, please don't. It breaks a lot of things. So how do you assign an address on a /64? Well, DHCP6 exists, and it works pretty much like you think it does. It's very similar to how DHCP4 works. The one little trick is there's a couple of bits in the router advertisement that you have to set, the managed bit and the other bit. It tells it to use DHCP6 or tells it to get resolver information from the DHCP6. You don't need to use DHCP6 to deliver resolvers. If you are dual stacking a network, and that's what we call it when you run IPv4 and v6 on the same subnet, you can do name resolution over IPv4 just fine. So usually just turning on the M bit and having it DHCP6 hand out addresses works just fine. The other method, though, is stateless auto configuration. And this is kind of IPv6's original party trick. Yeah, I know it's not entirely original, but it's really kind of cool. It does not require any additional infrastructure. It is the original method in the specification and therefore predates even the existence of DHCP v4. So how does Slack work? Well, basically your device will take its MAC address and use the EUI64 method to break that up into a 48-bit number. And I always get it wrong. I can never do it right by hand. You cut it in half and you flip a bit and you like wave a chicken or something, but you get a 64-bit number out of your 48-bit MAC address. Now, for the prefix part, you slap on the link local prefix, FE80, and now you can have layer 3 communication with your gateway. You are going to then either solicit a router advertisement or just hear one, and this works very much like probe and probe response and beacons. There's a lot of similarities there, and just like that, a router advertisement can contain informational elements that delivers information to your device like resolvers on an IPv6 only network. So that's a real great similarity for you to think about when you're starting to learn IPv6. So great, what's the problem? That EUI64 address is never going to change. If I wanted to track someone all over the internet, then knowing that the last 64 bits of their IP address is always the same would be a really good way to do that. So that's bad. What can we do about it? The first solution that was come up with is called privacy addressing. I did my first deployment with a great Indian engineer at my company, and so I call it privacy addressing still. And what basically happens is your host generates a random 64-bit number, and then it does something called duplicate address detection, which is basically like an ARP to see, but it's IPv6, so it's a neighbor solicitation going, is anyone using this address? If no, I'm going to use it, and then you go right on using it. The problem is that it can change very frequently. When we first dual stacked the corporate network at Yahoo, we thought, oh, we're just going to see this like once in the morning when people come in. No, we saw this traffic all day, and at the time, Aruba was still forwarding those as broadcast frames, so our broadcast traffic exploded. It's much more sane these days. Every platform I've tested handles neighbor solicitation and duplicate address detection correctly, but it still happens pretty frequently, and your address can change. So because of that and that instability, they came up with another method, and this is like the worst RFC name ever. I've just been calling them secure addresses. And so what happens is you take a bunch of variables, the prefix number, the name of the interface, so like on a Mac, it's like EN0, whatever the actual name of the interface is, the network ID, and in the spec it specifically says it's optional, but that can be the SSID, And the dad counter, that's if you try this once and it fails, you increment that one and try again. And a secret key, which is implemented when you first install the OS. You throw that all into a one-way cryptographic hash, and voila, you get a stable address that is based on where you are at the time it happens. So you do it at home, you're gonna get one address. You go to work, you're gonna get a different interface identifier. You come back home, you'll have the same interface identifier, but it'll be different from the one at work, so you can't be tracked everywhere. They really like this one because it's a lot more stable, and so you may go, okay, does anybody do this? Well, yeah. So thank you, Comcast, for providing great IPv6 support. This is thank you, Comcast. I love your v6 support. And this is a screenshot from my Mac at home. So we've got everything. I've got a link local address that's secured. That's what the secured mean. That snuck in sometime around Mojave. I've got a global unicast address that's a private address that's already deprecated. I've got one that's active, and I've got a secure global unicast address that's probably in use. So that's awesome, right? I mean, that's pretty cool. What's the problem? It presents a problem for those of us who operate networks if you are in a situation where someone's going to come to you at some time and say, who was using IP address foo at time bar? And for me, that's my security guys. For the folks at on the universities, I'm sure that's someone, bit torrenting, whatever. So there's no easy way to provide host tracking. There's no server, there's no logs. So you might say, okay, given all of that, I'm just going to run DHCP. It's going to give me the infrastructure that I'm used to, so I can do that, right? No, you can't. Well, why can't you? Because we're wireless engineers, and Android does not support DHCP6. And when I say it doesn't support it, it's like, you know that Taylor Swift song where she's like, we are never, ever, ever getting back together? Android is like, we are never, ever, ever supporting DHCP6. There is an epic flame war on Nanog a while ago that made ghost frames look like a border skirmish. So, I mean, it got real. So, you have to use Slack, you have to support Android. Although, side note, I believe Cisco IT did deploy an IPv6 dual stack network, and they just said no Android. Okay, that's a bold move. I can't quite get away with that because my company makes Android devices, so I'm pretty sure that's going to get a no. So if you're going to use Slack, how do you get the information you need into your security information event manager? Well, you can do SNMP polling. If you're old enough, you can do expect scripts. We literally did this back in the, I see someone laughing in the back. We did this back in the day when there were no SNMP MIBs yet to allow us to pull the neighbor cache. You can run an agent in a container on your gateway device. I think this is my Cisco SE trolling me because he really just wants to try to get me to play with containers on iOS XE, and he thinks he's going to trick me into doing that with this idea. And your platform may support neighbor cache logging. iOS XE does, but its limit is 1 message per second. I don't know if that's going to be enough. So you're like, are you kidding me? Are you serious? Yes, I'm absolutely serious. This RFC was written by folks from Apple and Google. And it's about their availability. They want hosts to be able to consume as many addresses as they can for various reasons. But when this problem of host tracking is addressed, they just say, yeah, this is what you should do. We do it. These other places do it, so you should do it too. I'm not sure I agree with that, but at the current state of play, it's kind of what you have to do. So that's pretty much all I have, but if you're looking at doing your first IPv6 deployment, feel free to hit me up on Slack or slide into my DMs because I love deploying v6. I love building address plans. That's the fun part. And if you have any questions, I'm always glad to help. Thanks.